All right, let's check out our next section today on page 277. Today's the day, people. Today is the day. This is the section that we've been preparing for this whole unit. This is it. All right, do you guys remember when we initially first started this unit, I told you our ultimate goal was to eventually be given a graph, and we're going to write the equation, or I'm going to give you an equation, and you're going to have to graph it. Sound familiar? Today's the day. Okay, we're actually going to do that. So on the first page, we have 4 different graphs, and we're going to take the time to pick apart and analyze different characteristics that the graph has, and we're going to use those characteristics to help us figure out what the equation of this graph would be. Okay? No calculator. We're going to do all this old school in our heads. Okay? So for all of these, since we're dealing with rational functions, we should at least anticipate a fraction of some type. So we'll go ahead and draw that bar. Where do you want to start? We've talked about so many different characteristics related to rational graphs. Can we just pick one to maybe start with and think about how that would be related to the equation? What do you think, Logan? Okay, where's our vertical asymptote?
1.
X equals 1. Okay, so if we have a vertical asymptote at x equals 1, think about what the related factor would be and where that factor should be located in our fraction. What do you think, Elsie? X minus 1 in the bottom. Good. Okay, so if it's a vertical asymptote, it's an undefined location, aka a restricted value, and restricted values show up in the bottom of a fraction because we know we can't divide by 0. Okay, so x minus 1 would be in the bottom. Can we pick apart a different characteristic? Good, Lizzie? Okay, so x equals negative 1 is a whole. Think about what the related factor would be and where that factor should show up in our equation. Yeah? Top and bottom. Okay, so what would the related factor be? X plus 1. Okay. All right, any other characteristics? We did wholes, vertical asymptotes. If we roll through our list, okay, wholes, vertical asymptotes, x-intercepts, y-intercepts, horizontal asymptotes. Can we look at any of the other ones? You have an idea, Blair? Yeah. Okay, horizontal asymptote at 0. How does that location of the horizontal asymptote relate to our function? Yeah? Higher in the bottom. Okay, so bottom heavy function. So in terms of our powers, we know that the bottom should have a larger degree than the top. Now, notice how we initially wrote our equation with factors. Maybe if we expand them, okay, get into standard form, we might be able to see those degrees or powers a little bit better. So let's see, the top would be x plus 1. If we expand the bottom, go through FOIL, we'll get x squared plus x minus x will cancel, and then minus 1 on the end. So when we expand it, it looks like we have a bottom heavy function. Okay, power of 2 is bigger than a power of 1. So far that's fitting our description for the horizontal asymptote. What about any of the intercepts? X or y? Yeah? Y-intercept at negative 4. Okay. How is that related to our function? let's think about it. If we have a y-intercept, that means our x value is 0. So if you plugged in 0 for your x's, you're basically going to be left with your constants on the end. And if we divide those, 1 over negative 1 would be negative 1. But according to the graph, it has to be at 4. So somehow, how can we get this division to be 4? Do we have to change it? Yeah? What do we have to change? Yeah?
Just multiply the top by 4.
Okay, multiply the top by 4. So over here in this factor, let's put a multiplier of 4 out front. And if we expand it, we can kind of distribute that 4 in. So that would make this 4x plus 4. And 4 divided by negative 1 would give us the y-intercept of negative 4. Okay, notice how we did not change the location of a hole. We did not change the location of a vertical asymptote. We still have a bottom-heavy function. Okay, so by multiplying by 4, we didn't change any of the other characteristics. Okay, we were just able to change the location of that y-intercept to fit the graph. All right, so far so good. What about an x-intercept? Yeah?
Not gonna be any, because there's the asymptote.
Okay, so there's no x-intercept. Looks good. If we had an x-intercept, can we think about how that would be related to the function? Because we might see one in the future. If we had an x-intercept, how can we show that concept somewhere in here? Yeah? It'd be in the numerator. Okay, we would have an additional factor in the numerator, but we don't have that going on here, so I think this is what we're going to be left with. Okay, so leave it in factored form, leave it in standard form. Either way, it seems to check out with all of the other characteristics. Okay, so we're going to pick apart all 5 different properties or characteristics that we've been talking about, and then making sure that those show up appropriately in the function themselves. Okay, so let's try the next one. All right, holes, vertical asymptotes, x-intercepts, y-intercepts, horizontal asymptotes. Where do we want to start? We're going to check all 5. Okay, Grace? Okay, so what's the factor and where's it located? There we go. Okay. So a hole is 0 over 0. Okay, it's a factor that cancels. It's in both places. Looks good. Can we throw in any other factors? What do you think, Lainey? Okay. So what would the related factor be and where is it? On the bottom. Good. Can we pick apart any other characteristics? Let's see, we're left with x-intercept, y-intercept, and horizontal asymptote. What do you think, Grace? At y equals 2. Okay, so what's that telling us about the equation? They're both the same. Okay, so the degrees are equally heavy. Okay, so we're going to have the same power up top as we do on the bottom. Now, based off of what we have so far, we can think about, anticipate, if we were to expand this, we'd have an x squared on the bottom, but only an x to the first up top. So since our horizontal asymptote is somewhere other than 0, we know they have to be the same. So there must be some other factor up here so that we can have 2 x's up top and 2 x's on the bottom. Can we kind of figure out what this missing one is? Where'd that come from? Okay, so x equals negative 1/2. What would the related factor be? Okay, so you can write x plus 1/2. That's definitely fine. Or something similar to the divide and slide process. You can take this 2 and slide it out front. That would make it 2x plus 1. Okay, so either one of those factors would be perfectly acceptable. One of them, though, might make a little bit more sense than the other one. We'll see why in a second, yeah?
Is there a way to find that point exactly?
This one?
Yeah.
Just based off the graph, I'm not sure. We would have to have the equation to figure it out exactly, but that's what we're trying to develop. So we'll just take our best guess and estimate it at about 1/2. Yep, educated guess. Alright, so it seems like if we were to expand this, we would have equally heavy numerator and denominator. So let's actually see what that looks like. If we multiply the top out, FOIL process, we'll have 2x squared, we'll see x minus 6x, so minus 5x, and then minus 3. On the bottom, we'll have x squared minus 7x plus 12. Okay, so they're equally heavy. Can we confirm that the y asymptote or the horizontal asymptote is actually at 2? How does our equation verify that? Yeah?
Because our leading coefficients divided by each other equal to.
Equal to. Okay, so this is why it might be more beneficial for us to use the 2x plus 1 factor instead of the x plus 1/2 factor. Because if you use this one, you would not have that leading coefficient of 2 out front. So it might not be, even though technically this is still an okay factor, it might not lead you to the result that you were looking for. So try to move that bottom number in front of the x so that you can see the horizontal asymptote a little bit better. Okay. All right, so that checks out for the horizontal. Let's see. The last one we need to check is the y-intercept. So if we take a look at the constant terms, negative 3 over 12, that'd be negative 1/4. And visually, that seems to be correct based off the graph. Okay, we're a little bit below the origin. So I'd say this is a good equation. Okay, it fits all the properties and the characteristics that we identified on the graph. All right, let's try the next one at the bottom. Can we pick apart some characteristics? Yeah, Elsie? Okay, so what's the related factor and where does it go? Top and bottom. Okay, so holes in both places. Looks good. Anything else we can pick apart? Yeah?
So vertical asymptote at x equals negative 3.
Okay, so related factor and where is it? Wanna keep going?
It'll be x plus, or x minus 3. Or plus 3, yeah. Plus
Okay, so where can I put that factor?
3 on the denominator.
In the bottom. Okay, so x plus 3 in the bottom. Looks good. So we looked at the hole, we looked at the vertical asymptote. Let's keep looking. Can we find another characteristic? You want to keep going, Matt? Yeah.
Y-intercept.
Y-intercept, okay. That's it, -1. So eventually, when we get our standard form equation, when we divide the constant terms, we should get -1. Okay, so we'll save that for a little bit. Can Can we find some other ones? Go ahead, Grace.
There's an x-intercept at 3.
Okay, so how can we use that in our equation?
The related part is x minus 3
And it's up top. Okay, so x-intercept goes at the top. All right, anything else? Can we keep going, Grace? Yeah.
There's a horizontal asymptote at 1.
All right, so what's that telling us about the equation? Equally heavy. Okay, so equal degrees. So if we were to expand it, they should be the same power. And I think since we have 2 factors up top and 2 factors on the bottom, that would be the case. So I don't think that there's any more factors that we need to throw in here because they're already equally or equal in value. So let's go ahead and distribute, do a FOIL process. We'll get x squared minus x minus 6, and then x squared plus 5x plus 6. Now if we go back to Matt's y-intercept, notice how negative 6 divided by positive 6 would give us the value of negative 1. So it seems like our factors were good. We have equally heavy degrees, so that checks out for our horizontal asymptote. We should also verify the location of it. Notice how if we do the division of the leading coefficients, that would be 1, and that's where our horizontal asymptote is. So it seems like all 5 of these characteristics are checking out. So I'd say we're good. Do you guys want to try the last one? It looks a little different, but it still works the same way. Okay, roll through your different characteristics. See if you can find the equation. We'll check it out in a little bit. Alright, let's check this out. Can we find any factors? Top factors, bottom factors, what'd you get? Let's not all get excited at once. Yeah.
I got x plus 4 and x minus 3 and 1 for the vertical asymptotes.
Vertical asymptotes. Okay, so negative 4 is a vertical asymptote, so we'll have x plus 4. Positive 3 is a vertical asymptote, so x minus 3, both on the bottom. Looks good. What about some factors up top? Good, Matt?
X plus 2 and x minus 1.
Where'd those come from?
They're x-intercepts.
X-intercepts. Okay, -2, +1. Looks good. Are there any other ones that you found? I'm seeing head nods. Okay, so if those are the only ones, let's expand it. We'll have x squared plus x minus 2, x squared plus x minus 12. Okay, how does your equation confirm some of the other characteristics this graph has? Because realistically, we only checked out 2 of them in here. What do you think, Blair?
Leading coefficients are divided by the y-squared.
Okay, so we're horizontal
Horizontal.
asymptote. All right, we're equally heavy, so our horizontal asymptote is somewhere other than the x-axis, which is clearly the case. And if we do the division of the leading coefficients, we get 1, and that's the location of the horizontal asymptote. So good so far. What about another characteristic? Yeah?
Y-intercept.
Y-intercept. Okay, so -2 divided by -12 would be 1/6. And the y-intercept, we can't really tell for sure, but 1/6 kind of seems to make sense. Okay, just above the origin. How did we do? Pretty good? Okay, so for those 4 examples, we started with a graph, and then we wrote the equation. We're going to flip it, because now we're going to start with an equation, and we're going to try to graph it by hand. Okay, we'll confirm on the calculator. I'll do that up top here, but I want to make sure we can do it by hand first. So looking at the function at the top, in order for us to graph this by hand, it might be beneficial if it was in factored form. That way we can pick apart some of the different characteristics for the graph. All right, so let's try to factor it. The bottom's going to be pretty simple. 2 numbers that multiply to 3 but add to 4. We'll get 3 and 1. For the top, we have an a value of 2. So we'll do a times c, which is -6, b value of 5. You can go through grouping or divide and slide, whatever you prefer. Can we think of the 2 numbers that multiply to -6 but add to 5? Good, Julia? -1 and 6. Okay, seems to work. So grouping, divide, and slide, whatever you prefer. Go ahead and do that. Bless you. Alright, so I got 2x minus 1 and x plus 3. Alright, so now it's in factored form. We should be able to figure out some characteristics. Let's roll through our options. Can we find any vertical asymptotes? Good, Olivia? Yeah. Say it again. X plus 1's the factor. Okay, and it'd be -1 if we solved it. Okay, so x equals -1. How did you know it was this factor to look at? Okay, does not cancel. Okay, you can say left over in bottom. Looks good. So as soon as we find a characteristic, I think it'd be beneficial if we just went ahead and graphed it, because that's our ultimate goal anyway. So at the grid on the bottom, we'll throw in a vertical dotted line at -1. Can we find another characteristic? What if we moved on to holes? What do you think, Lainey? Okay, because x plus 3 cancels. Alright, so graphically, if we go to the x spot of -3, we know we're going to have a hole somewhere at this spot, but we don't exactly know where just yet. How can we figure out the heights of the hole? aka the y value. We know it's somewhere here at -3, but can we get a little bit more specific in terms of the height? Yeah. Okay, so if we actually simplified the factors, we know x plus 3 goes away. We're left with 2x minus 1 up top and x plus 1 on the bottom. Let's go ahead and plug in -3 into this simplified fraction. We'd have -7 over -2, which would be 3.5. Okay, so at the spot of -3 on the x-axis, we'll go up to 3.5 and put an open circle. Looks good. Let's try to find some more characteristics. Can we do horizontal asymptote? Do we have a horizontal one? Is it slanted? What do we think? What do you think, Grace?
It's at y equals 2 because the degrees equal each other.
Okay, so degrees equal, and how'd you get the 2?
The front factor.
Okay, so leading coefficient at the top is 2, divided by a leading coefficient at the bottom is 1. So 2 divided by 1 equals 2. Alright, so on our graph, we'll throw in a horizontal asymptote at 2. Let's try to find some more characteristics. What about an x-intercept? Good, Logan? Where'd that come from? Okay, and if we solve it, let's see, we'll add the 1, divide the 2, so we'll get a half. Okay, and we'll say because 2x minus 1 doesn't cancel, okay, left over in the top. So graphically, we'll put an x-intercept at a half. Let's see, we did 1, 2, 3, 4 characteristics. What's our fifth one? Which one haven't we looked at yet? Yeah? The y-intercept. Okay, so I know it's not a part of any of the, at least the questions up here at the top, but maybe down here we'll do a y-intercept. Okay, can we find the y-intercept for this graph? Good, Olivia? Where'd that come from? Alright, constant terms at the top. Alright, so -1, we'll plot it. Okay, so we went through all 5 characteristics. It's starting to take shape. It's kind of a skeleton graph right now, but we're eventually going to fill in the rest of it. Before we get there, though, can we figure out the domain and range before we even fill in the rest of the graph? Do we know which numbers we have to skip over? Let's see. Even though I don't have a graph yet, what do you think, Lainey? Sorry. Yep. It would. Okay, so how did you know you had to skip over -3 and -1? There you go. Okay, so for domain, we got to skip over the x value of the whole and then the vertical asymptote location. What about the range? If you were to drag your pencil low to high, is there anything we have to skip over? Let's see, I know I can start all the way at the bottom. As I start to drag up, I eventually reach the horizontal asymptote, which we said was at 2. So I gotta skip over that. And as I continue to drag, I reach the hole again, which has a y value that doesn't exist. We saw that that was 3.5. So we'll have to skip over that one as well. Alright, so notice how for both domain and range, you gotta skip over the asymptote and the hole. It just depends if it's the vertical or the horizontal for the domain and the range. Alright, let's fill in the rest of this graph. So we're starting to get a general shape. We know we're going to have some type of curve in the bottom right square and some type of curve in the top left, because that's where some of our characteristics fell. I want us to be a little accurate though. Try to get 3 points on each side. So for instance, this bottom right-handed piece, we already have 2 points. Can we get a third one in there, just to be a little bit more accurate? We're done with our characteristics. Okay, we found all of those. But how can we get a few more points to help us out? How can you find a point on a graph? Yeah? Sub it in. Pick any point you want. Okay, so what x value are we feeling today over here? 2? Okay, let's go ahead and plug in 2. Bless you. Now, you have some options, okay? Because technically we have 3 different equations. You could use the equation at the very top and plug in 2. You can use the factors that you found and plug in 2. Or you can use the simplified form that we had for the whole and plug in 2 there. It really doesn't matter. Okay, you just pick which one you want to use. I think the simplified form might be a little easier, less to work with. So if I plug in 2, and for these x's, I'll have 4 minus 1 over 2 plus 1, 3 over 3 is 1. Alright, so plug in 2, get out 1. Now that we have our 3 points, we're going to kind of play connect the dots, but since we have asymptotes, we cannot touch or cross those, so we're going to kind of hug them as we draw the graph. So we're going to hug the vertical one on the left-hand side, play connect the dots, and then we'll hug the horizontal asymptote to the right. So there's one piece or one branch, one section of this graph. For the top left-handed section, we already have a hole to kind of guide us, but let's try to find 2 more points just to be a little accurate. So I don't know what numbers you're feeling. Let's try -2. Alright, I'm going to plug in -2 for my x's. I'll get -4 minus 1, -2 plus 1, -5 over -1, which is 5. Alright, so plug in -2, get out 5. Pick another point you're feeling. Maybe -4. Plug it in. -8 minus 1 over -4 plus 1, -9 over -3, +3. So now we have 3 points to kind of help us with this branch. We'll hug the asymptote, play connect the dots. Do not go through the hole. Okay, that's supposed to be an open circle. And then you'll hug the vertical asymptote as you go up. No calculator. How do we do? Pretty good? Okay, now I just want to show you briefly. If you wanted to check your work, you could on a graphing calculator. So if you had one available, we can go ahead and type in the original function at the top, but you have to be careful on how you type it in. So for your calculator, if you want to do a fraction, you got to put the whole top in parentheses or the whole bottom in parentheses, unless you are aware of how to do that special fraction command so it has the boxes for the top and the bottom. I think it's a little tedious to find that, so I just type it in with parentheses, but it's completely up to you. But see, I'm not familiar, or as familiar with that as you might be, so for me it's one of those things that if I did it all the time I'd be used to it, but I don't.
The only use to is to do it on
I know. Well, maybe I have to start. Maybe I have to start doing it all the time. Okay, I'm gonna set my window. It looks like we go from -8 to +8. All right, and I'm gonna hit graph. That looks pretty good, right? With what we had on our paper. Do you notice anything interesting about the graph on the the graph on the calculator compared to the graph on your paper? Yeah? It doesn't show the hole. Okay? The hole is so tiny, it's like the tip of a needle. Okay? The hole is so tiny because it's only one spot that your calculator is not capable of graphing it. Okay, something with the pixel or how close you can get to it. So visually you can't see it, but you can confirm that there's a hole at this spot. So if you were to hit trace and simply type in, what was our hole location? -3. Notice how it would not give you a Y value. So you can't see it, but you can confirm graphically by going through that typing command. Okay, there's no physical Y value there. It's just so tiny the calculator can't graph it. Do you understand that? Technology can only do so much. Okay, so that's why we did it by hand. Okay, we know that there should be one there anyway. We doing okay? All right, we'll do more with the graphs tomorrow. We're gonna call it a day.